Alright, welcome back to another video lesson, everyone. This is lesson 8.5, all factoring with area. Okay, so I'm just going to give you a quick rundown before I go into the lesson. So if you see two terms, it's possible that you might be looking at difference of squares. If that's the case, then we can use this following formula, which is a squared minus b squared equals a minus b times a plus b. If you have three terms, so what we try to do here is we try to split the middle term, okay, which means we end up with four terms. But then if a is equal to 1, don't forget we can use simple factoring. Okay, so we don't have to do factoring by grouping. But if a is more than 1 or it's not equal to 1, then we do factor by grouping. If you're given a polynomial that has four terms, then you can use grouping, which means you get to use GCF twice. Okay, so with that said, on every single problem, make sure that you check to see if there's a GCF. So I'm going to do the first page in this video, and then I'll do the second page on the next video. So let's start with number 1. Number 1, first ask the question, is there a GCF? So does 3 go into 17 and 10? It doesn't, right? So that means for this one, there's no GCF, so we can't take out a GCF from here. So since there is no GCF, and we see that this has three terms, then what I'm going to do is I'm going to split the middle term, okay, meaning I need to find multiples. So find multiples of 3 times 10, which is 30, that's a times c, and I need to find the multiples of 30 that when I add them, they add to, in this case, the b term, which is 17, okay, that's the b value. So then the multiples of 30 that add to 17 are 2 times 15, right? So then what I'm going to do next is I'm going to split up 17 as 2x and 15x. So I'm going to group conveniently 3x squared with 15x because they are both odd numbers, right? Or odd coefficients. So plus 2x plus 10. Then I'm going to group these two terms together and these two terms together. Then find a GCF twice, which is what we're saying here. So GCF of 3x squared plus 15x is 3x. And GCF of 2x plus 10 is 2. And notice that 2 has a plus in front of it, so it's plus 2. So then factoring out the GCF of 3x, then the first group becomes x squared plus, x plus 5, right? So then this is x plus 5. And then when we factor out a 2 from the second group, we have another x plus 5. And as you can see, we have x plus 5 in the two groups, so we can factor out x plus 5 as a GCF and then put together 3x plus 2. And this is that quadratic in standard form, now in factor form. Okay, number 2, GCF again. This is three terms and we can't see a GCF. Now notice, in this case, a is equal to 1. So we can use factor by grouping, but we don't have to. This is simple factoring. So all we have to do is find the multiples of a times c, given that a is 1, right? So I'm going to write that down. A equals 1. So then I can find the multiples of 1 times 20. So multiples of 1 times 20, which is 20. Then I need to find the multiples of 20 that when I add them, they add to 9. And the only multiples that do this are 4 times 5, right? So then this quadratic factors as x plus 4 times x plus 5. So notice again, I did not use factor by grouping. Even though I could, it wouldn't be wrong, but I don't have to face 1. Okay, so do not make it complicated when you don't have to, only when needed. So if a is not 1, then we do what we did on number 1. Right, number 3. GCF again. So in this case, we had no GCF, and in this case, there's no GCF either, so no GCF. All right. So then here, what we need to do is, since a is 1, again, notice a is equal to 1. So then we can do simple factoring. So multiples of a times c, a being 1 and c being negative 15. So multiples of negative 15, that when we add those multiples, they add to our b value of 2. Well, for 15, that's simple. It's 3 times 5. But notice that when we add them, we end up with a positive 2. When we multiply them, we end up with negative 15. So that means you got to have opposite signs. So to get a positive 2, that means that 3 has to be minus. Okay. So then this factors as x minus 3 times x plus 5, and we are done with this problem. Right. Next example. So for example number 4, again, there is no GCF, and this is again 3 terms. So no GCF. Then we do notice that there's a negative lead. So on the lesson from yesterday, one of the videos from yesterday, let's factor out the negative lead first. So then this becomes positive x squared, this changes to positive 3x, and this changes to negative 18. So now notice that a is 1, right? So if a is 1, again, we can use simple factoring. So find the multiples of negative 18 that when we add those multiples, they add to, in this case, 3. Okay, so the only multiples that 18 that do this are 3 times 6. But notice when we add them, we end up with a positive 3. When we multiply them, we end up with a negative 18, which means they gotta have opposite signs. So the only way that's possible is if the 3 has a negative, okay, or a minus. So then keep that negative lead, x minus 3 times x plus 6, and this is factored completely. All right, next example. Is there a GCF? Well, those two go into 26 and 24. The answer is yes. So there is a GCF. Okay, so let's factor it out. So then this becomes x squared minus 13x plus, instead of 24, 12. Now, notice again, a became 1, right? So a is 1, the coefficient of x squared is 1. Once we factor the GCF, so then we need to find the multiples of a times c, which is 1 times 12. So multiples of 12, that when we add those multiples, they add to our b value of negative 13. Well, that's simple because 1 and 12 add to 13. But notice they have to add to a negative 13 and multiply to a positive 12. So the only way they multiply to a positive 12 is if they have the same sign. Okay, so that means they both have to be negative. So then I'm going to keep that 2. And this is x minus 1 times x minus 12. Again, if you have x minus 12 first and x minus 1 second, it makes no difference. Okay, it's still the same thing. So this is that standard form quadratic in factor form. All right, so let's do the last example on this page. GCF for this one, there's 2 going to 11 and 12. Well, it goes into 12, but it doesn't go into 11. So that means there is no GCF when it comes to the coefficients. What about the x's? We have x to the third, x to the second, and x to the first. So the answer is there is a GCF, and the GCF is x, because this is x to the third, x to the second, x to the first. So x is the GCF, so then this becomes 2x squared plus 11x plus 12. Now, since a is not equal to 1, this is not simple factoring. So we still need to multiply multiples of 2 times 12. Okay, so multiples of 2 times 12, which is 24. So multiples of 24, that when we add those multiples, they add to our b value of 11. And the only multiples of 24 that do this are 3 times 8. 3 times 8 is 24. 3 plus 8 is 11. So then keep that GCF of x, 2x squared, and split up 11x into 8x plus 3x plus 12. Again, notice what I did. I put evens with evens. This is even and this is odd. So odd goes with 12, and that will make it easier for me to see the GCF. But you can do this however you want. So GCF of the first group is 2x. GCF of the second group is 3. So not lose that x yet. Okay. So then we have GCF of 2x. And then this becomes x plus 4. And then this is plus 3 times x plus 4. Nice. I should use braces here. As long as you know what you're doing, it should be fine. Okay. So then I'm going to keep that x still here. I'm going to factor out x plus 4 because they have that in common. The two groups do as a GCF. And then put together 2x plus 3. And now we're done factoring. Okay, so this quadratic is factored completely. So this is a cubic or a third-degree polynomial that we just factored. All right, I'll do the other page on another video. Thank you for watching.